Chapter 5, Section 8, Question 0. There is no question 0, but this is a question that is going to help you prepare for the rest of this section. So what we're going to do is remember back to Chapter 1. It all started with Chapter 1 where we had properties of real numbers. And one of the properties of real numbers was the multiplicative property of 0. That says if you multiply things together and it equals 0, someone has to equal 0. So first, I can equal 0. And we show our handy dandy work. And we get that x equals -8. Okay, we have an answer, but wait, I can equal 0. We could have 4x plus 3 equals 0. College professors really liking to see this handy dandy showing work. Ooh, I have a fraction. But wait, I can equal 0. Any of these pieces that have an x could equal 0. Showing this wonderful work, adding or subtracting to both the left and right sides of the equation. Very wonderful work. These are the 3 answers for this equation. Now, if they wanted you to write it as a single answer, you would write x equals, preferably in order from least to greatest. So -8 first, comma, -3/4, comma, 2/3. That would be your answer. Now, there's this one. As students get further in math, they may find that their teacher does not require them to do all of this. But there's some patterns going on here, so that you might be able to, at some point, look at x plus 8, know that the answer is -8. So if we were to find something like x plus 4, the answer would be x equals -4. Now you'll have to know whether or not your teacher needs you to show the work or not. I would rather you show the work, but at this level of math, I am actually okay as long as you can do this without making mistakes. So let's see, any others that have just a regular x? X minus 3, positive 8, the answer was -8. -3, the answer is positive 3. You're going to find that as we go through this, you will find that in parentheses land, things lie. It says x and a -7. The answer is going to be x and a positive 7. X and a plus 9, the answer is x equals a -9. X plus 5, we'll have x equals -5. Two-step equations. You'll notice that everything here is pretty much a two-step equation. So here we're going to subtract that over. So this is a positive 3, this is a -3, and then divide by 4. This sign changed, and this sign changed, and you stuck that on the bottom. Let's try it here. This sign changed, and you stuck that on the bottom. We might be able to find this without showing work. The reason I started off showing work is that's always going to work. And our two-step algebra equations is where we almost always start off our algebra. So here, x equals, change this sign from positive 7 to -7 and stick the 3 on the bottom. X equals, change this from a positive 3 to a -3 and stick that on the bottom. Change this from a -3 to a positive 3 and stick the 4 on the bottom. It goes from a plus 7 to a -7, put the 5 on the bottom. A -6 to a positive 6 and stick the 7 on the bottom. And 7 is going to be equals -7 with the 6 on the bottom. But, ooh, look at that. There's an x all by itself. We haven't encountered that before. But what we do know from here is I can equal 0. So let's take a look. I can equal 0. Oh, well, that's very easy. The answer is x equals 0. Now, over here, we can look at 2x equals 0. Divide both sides by 2, and we'll still get that x equals 0. Now, another way to look at this is 2 does not equal 0, so therefore the x must equal 0. Each piece, somebody has to equal 0, but since 2 will never equal 0, 2 is not even something we have to worry about. But if this makes more sense to do that Also be very careful because some students get messed up when you have a 0 divided by 2 and they say it's undefined. So something to remember from back in chapter 1, zeros on the top are good and give you the answer 0, but dividing by zeros are bad. That's what gives you the undefined. Next, we're going here. -7, so positive 7s, put the 6 on the bottom. This says +1, so we use -1, put the 5 on the bottom. That says -1, we put +1, put the 4 on the bottom. That says +6, we're going to use -6 and put the 5 on the bottom. That says -2, we put +2 and put the 7 in the denominator. We have -1/6. Are you seeing the pattern? Here, we could just know that the answer is x equals 0. But if it helps you to put -7x equals 0 and divide both sides by -7, do that and get x equals 0 anyway. X equals, change the sign, put this leading coefficient in the denominator. Change the sign, put the leading coefficient in the denominator. If you want to take a look at this more, you can pause it. If you want, you can also rewind it. Try them all yourself. These are the answers. So I would not, even at pretty much any level of math, give you a problem that has 1, 2, 3, 4, 5, 6, 7, 8 answers. But you will have some in the college classes that will have many answers. You'll also have some that have repeating answers. But what I usually use this for is when we have a class, have all the students come up and do at least one of these so that you get some practice before we get to the actual Chapter 5, Section 8 questions. Chapter 5, Section 8, Question 1. This problem will come back to us over and over again in Chapter 5, 6, 7, 8. Right here, we've actually started with this back in Chapter 3, f of a. So f of a means that all of these things that were x's will now become a's. And all I want is this part here. So 8a squared plus 6a minus 8. All of this is equal to f of a, but all of this is also equal to 1. Notice, I did not write any x's, I didn't write any f of a's, and I didn't write any f of x's. This is an equation. So the first thing is we're going to plug. The second thing is we're going to make it equal to 0. Now, I could move it all to the left or all to the right, but I really want this first term, when we're writing it in descending order by degree, to be positive so I can factor it. So I'm going to subtract 1 on both sides. Showing work, very nice for our college classes. Then I'm going to factor it. Now, some people might be able to look at that and factor it, but if you know your a equals 8, your b equals 6, and your c equals -9, we can on the side make this as easy as a, b, c using our snowflake method. A times c is -72, b is 6. 72, breaking up to get to 6. Let's see, 72 could break up as 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 and nothing nice, 6 and 12. Because this is a -72, one of them will have to be negative. Because b is positive, it'll have to be the smaller one that's negative. So I'll have -6 and 12. On the top, we're going to have our a's. And in this case, our a is 8. Reducing 4 and -3. Divide by 4. And let's see, that one was dividing by 2. This one's dividing by 4. 2 and 3. Reading going down. Coming back over here to our problem. I need to see this step. I need to see this step. I need to see the third step, which is factored form, equal to 0. Make sure you have this equal to 0. The entire 099B class is based on this concept here. So we've got to get it right. We have 4 and minus 3, so that's 4a minus 3. Many students are going to do 4x minus 3 because we often use x, but here we're using a. 2 and 3 gives us 2a plus 3. Make sure that you find all values of a. Make sure you're solving for a. Now, if you understood what we did on the last slide, you could possibly look at this and write the answer, but if you need to, you can do 4a minus 3, I can equal 0, and 2a plus 3, I can equal 0. And then show the work to solve those. That is always a good idea. Good habits to practice in math. Also, a lot of students remember that there is a pattern. They don't remember what the pattern is. That's why I keep going over this, is because if you just know that this is equal to 0, you could solve it on your own, and you will get these answers. If you're deep in it, and you have been doing these for a while, and you can see what the answers are, then I need, at minimum, line 1, 2, 3, and 4. If you don't need this, I will actually be okay without this for this section. If you don't need this or that, if you can factor this in your head, go for it. And if you don't need this and you can look at this and write the answer, that will be fine. So the minimum is 1, 2, 3, and 4. So plug, set it equal to 0, factor it, and of course, solve. Do make sure that you're solving for A, not for X. Chapter 5, Section 8, Question 2, Finding X-Intercepts. If we think back to Chapter 3, we learned about X-Intercepts. X-Intercepts are where a graph, like a parabola, crosses the x-axis. So this is an x-intercept. And something we learned about this is someone has to equal 0. This is the x-axis. So this would be x is equal to a number, and the y-axis is the vertical axis. Since it didn't go up and down, the y number would have to equal 0. And for the other one, the y number would have to equal 0. That is an important first step because we always want these to be equal to 0. So the very first thing we're going to do is make y equal to 0. So we get 0 equals 2x squared minus x minus 3. We've talked about the fact that some of the teachers don't want the equal 0 on the left, they want the equal 0 on the right. I'm going to show you very quickly how to fix that. Bam! The equal 0 is now on the right. Same equation, and that is by the symmetric property of equality. Hey, if you have 1 plus 2 equals 3, 3 is equal to 1 plus 2. It all works out. All right, we're going to factor this. If you can do this in your head, remember you can always use the snowflake method, but if you know that 2x squared only breaks up as 2x and x, 3 only breaks up as 1 and 3, I could have 1 and 3, or I can have 3 and 1. I happen to know that we're going to have 3 and 1. This will give me a 3x, this will give me a 2x, and we need to get a negative x. So that's the negative and that's the positive. Hey, if this is what it takes to help you check it out, that's great. But I need to see it equal to 0. I need to see the factored form. I need you to solve it. Remember that if you can, just look at it and write the answer. I will take that at this level of math. So solving it, I will change that sign and stick that on bottom. 3 over 2, and change that sign, and there's nothing to stick on the bottom. You'll get negative 1. Those are my 2 answers. But write the answers as ordered pair. X-intercepts are supposed to be ordered pairs because PPCC said so. So we have x is 3 over 2, comma 0, and y is, nope, the other x is negative 1, comma 0. Be careful. Some students put parentheses there, in which case that would become an x and that would become a y, and that doesn't make sense. This is an x and y is 0. This is a different x and y is 0. Those are your ordered pairs. That's what we're looking for. So y equals 0, we make it equal to 0, we factor it, we solve it, and then we write our answer. I'm going to use A and S for answer. There we go. 1, 2, 3, 4 steps. That's the minimum of what I need to see. Chapter 5, Section 8, Question 3. The Pythagorean Theorem. I hope that you remember the Pythagorean Theorem. So, formula, plug, work, answer. The Pythagorean Theorem is a squared plus b squared equals c squared. When I have a right triangle, A and B are the legs. Now, see that right angle there? The legs are the two that are by the right angle. So this is a leg and this is a leg. Since we have the commutative property of addition, this could be A and that's B, or this could be A and that's B. It does not matter. I'm going to define this one to be A and this one to be B. And that leaves C to be the hypotenuse, which is the longest side. And if you ever wonder which is the hypotenuse, you can take a look at this right angle here and make it into an arrow that says, that is C. That way we know that one is C. So here I have A squared plus B squared equals C squared. 2x squared plus x minus 1 squared equals 2x plus 1 squared. Hey, formula, plug, work, answer. Right there, if you have formula, plug, work, answer, we already have half of the problem done. The rest of it's going to be longer. But I could give you half credit for putting those two things there. Now, we have to multiply this out. 2 squared from back in chapter 1 gives you 4. X squared gives you x squared. From chapter 5, section 2, we can multiply that out. If you can, at this point, multiply it out without making all 4 terms, that's great. But it might be worth it on the side. X minus 1 times x minus 1. X squared minus 2x plus 1. The way we got that was we did x squared minus 1x minus 1x again for the insides and plus 1. That gives us x squared minus 2x plus 1. That's what goes here. Many students try and do it without writing it out twice, and they get it wrong. The reason is they get x squared plus 1. So they get this. And they're missing out on this term. That's going to cause problems in chapter 6 as well. So, since that might cause a problem, we're going to do the same thing with this. 2x plus 1 and 2x plus 1. We're going to write it out twice. Hey, this first one is 4x squared plus 2x plus 2x plus 1. 4x squared plus 4x plus 1. 4x squared plus 4x plus 1. If I combine like terms here, I will get 5x squareds, and this is going to tell us which way we're going to move everything. I have 5x squareds here, and I have 4x squareds here. I want this to be positive when I'm done with it, so I'm going to move everything to the left. This is a wonderful place to show a lot of work, because if you get even one of the terms wrong, you're probably not going to be able to factor this and solve it. I'm trying to move all of them over in one step. If that's confusing to you, you can move them over slowly. 5x squared minus 4x squared is x squared. Minus 2x and minus 4x is minus 6x. And plus 1 and minus 1, remember those are additive inverses from chapter 1. Those will cancel out. Additive inverses, additive inverses, additive inverses. And hey, we have the variables on the left equals 0 on the right. We have it equal to 0. That's wonderful. All we have to do is factor it, solve it, check the answer, and label it. That is a lot of steps. Many students are not used to seeing this anymore because they're waiting for a trinomial. This is a binomial. But it's not a difference of squares binomial. So the first thing that we learned is the first thing we forget. Sometimes you'll get a trinomial here, but sometimes this just has a GCF. And we can factor out an x, and we're left with x minus 6. My equal 0 did not line up. Here, equal 0. So, I can equal 0. X equals 0. And I can equal 0. This will give you 6. We do have to check it. So, formula. Plug. Solve. All the way down to here, we solved. Then we're going to have to check our answer. So if we check our answer, the way we do this is in chapter 5, the reason to cross out an answer is if it makes one of the sides 0 or negative. So if we take the 0 and we plug it in here, 2 times 0 is 0, this would be gone because it would have a length of 0. That doesn't make sense. No matter how short I am, I have a positive height. No matter how short this side is, it will have a positive length. That one's gone. Now we'll take 6. 2 times 6 is 12. 6 minus 1 is 5. And 6 times 2 is 12 plus 1 is 13. That works out very nicely. Now on some of the problems it does say to label it. And since x would only be referring to one side, you would put units. In this case, because x is not a side all by itself, I would say you don't have to label it. But sometimes the problem says label, in which case I would like you to label it. And now for a bonus feature. At some point in time, you will be encountering a problem like this. And you saw how long that problem was last section. So these are 4 of the most common Pythagorean triples. A Pythagorean triple is a set of 3 integers which can be the sides of a right triangle. A squared plus b squared equals c squared. You'll see these in a lot of math classes, especially geometry and trigonometry. So here, these are separated by 1. These are separated by 1, but these aren't. That wouldn't quite work. But if we look, we have these are separated by 1. Ooh, it could be this one. That's separated by 2. Ooh, it could be this one. So let's take a look. If this was equal to 5, then x would equal 6. 2 times 6 would be 12. And 6 times 2, 12 plus 1 gives me 13. This is a 5, 12, 13 right triangle. If you can, using these, figure out what the answer is, we already know that x equals 6. On an SAT problem, they might say, hey, what is the perimeter? In which case you would add these numbers up. They could say, hey, what is the longest side? What is the hypotenuse? What is the shortest side? In this case, it would be 5. They could ask you questions, but if you can figure out the sides without showing work, that will really save you time on an SAT, ACT, a multiple choice test. Can you do this in chapter 5, section 8, question 3? Heck no! You'll have to do it the long way. But this is also a way to check your answer. And these will be the ones that we'll be using pretty much the entire time. Now, be careful. We can take these and do stuff with them. I can take 3, 4, 5 and change it into 6, 8, 10. All I did was I multiplied everything by 2. I could take 5, 12, 13 and make it into 0.5, 1.2, and 1.3. I could change 8, 15, 17, and I could make it into 80, 150, and 170. So just by multiplying or dividing, I can change the look of them to try and hide them from you, because I know that these are the most common Pythagorean triples. Chapter 5, Section 8, Question 4, Introduction. Use X-intercepts to find an equation. So I have a picture here of a parabola, and it has an X-intercept. This is at -2, 0, and this is at -3, 0. I'm going to use those X-intercepts to say that x is equal to -3 and x is equal to negative 2. This is working the same problem that we did a few problems ago backwards. I need to get these equal to 0, so I'm going to add 3 to both sides. And I'll get x plus 3 equals 0. I'm going to add 2 to both sides. And I'll get x plus 2 equals 0. This will tell us what we're going to multiply together to get the polynomial equation of that graph. So we'll take x plus 3 times x plus 2 equals 0, and we will FOIL this out together. If you can do that all in your head, you'll get x squared plus 5x plus 6 equals 0. These are the two lines that I would need for full credit, half credit, and full credit. Notice that it has to be equal to 0. Why did we have to multiply it? It has the word polynomial. This is multiplying two polynomials together. This is a polynomial. Why does it have to have the equal 0? Because it has the word equation. This is not the last time we've seen this type of problem, and it's only going to get worse. So learn it now, so we'll be okay, because we'll see it again in later chapters. Chapter 5, Section 8, Question 4. We're seeing it again already. So here we have x equals 2/3, but wait, x is equal to negative 5 over 4. Notice that that negative is right in line with the vinculum. That is correct notation, but it's also saying that a lot of students will forget, so be careful. Now we want to get it all on one side equal to 0. We also want to get rid of the fractions. Almost every math class will have you get rid of the fractions. So this has an over 3, so same as we did in chapter 2 and in chapter, we're going to have it in chapter 6. We keep doing this, and that's because chapter 6 is a doozy. All right, equal sign, common denominators, pew pew, we get 3x equals 2. We're going to subtract 2 from both sides, and we get 3x minus 2 equals 0. Common denominator is 4. 4 on the bottom, 4 on the top. We're multiplying. Common denominator equals 0. Pew pew! We get 4x equals, hey, make sure you keep that, negative 5. Getting it on one side equal to 0, it's going to work. It's going to work. We have 4x plus 5 equals 0. Now, you don't actually have to show this work. But the reason I've done this is because since I started teaching it this way, more students will get this correct. There are some students who can work it backwards. Remember when we did change that sign and stick that on the bottom? They stick this in the front and they change that sign. Some people can do it without showing the work, but I'm not doing this just for the students who can do it all in their head. I want every single student to pass. This is how we're going to do it. So the two lines that are required, we need this times this is equal to 0. I need to see that. And then if you can multiply this together in your head, great. That's a lot yuckier than last time though. So we're going to show work because, hey, no shame in showing work. We have plus 15x minus 8x minus 10 equals 0. We have 12x squared plus 7x minus 10 equals 0. The two steps that I would require are this one and that one. The rest of this is all to make this clearer to everyone. Chapter 5, Section 8, Question 5, Type 1 of 2. You know it was going to happen. Word problems and factoring living together. Pictures, labeling, all of it. This is the last and hardest question in all of 099A. So here we have a rectangular garden, and I have handily drawn you a rectangle. It's not going to be like that in your homework, or your quizzes, or your tests. All right, a rectangular garden has a base or bottom that is 5 more than the height. 5 more than the height, so if x is the height, 5 more than the height. Remember this phrase from chapter 2, more than, less than, subtracted from, means we have to switch the order around. We're going to define our variables. The base is 5 more than the height, so the base is 5 more than the height, and the height is that. Hey, there are 4 things to solve a word problem. Define your variables, write the equation, solve it for all the variables, write the answer and label it. This is 1 out of 4. That is not enough to get you half credit. So we need to know some more. The area of the garden is 24 square feet. Ah, they have given us a label other than units. We'll have to use that. We need to remember about the area formula for a rectangle. The area of a rectangle is length times width. Many students at this level of math have forgotten that, so I draw out a little rectangle and I said, hey, if this is 2 in this direction and 3 in that direction, you can actually see that the area is 1, 2, 3, 4, 5, 6. So 2 times 3 equals 6. Length times width equals area. If that helps you remember it, great. So we have the area, which is 24, monomial times binomial, distributive property from chapter 1, getting everything on one side equal to 0. I really want this x squared term to be positive because otherwise we'll have to factor out a negative. So we're going to move everything over to the right. I am not one of the teachers who needs everything on the left-hand side equal to 0. I can have it on the right-hand side equal to 0. But if you are in a class of a teacher who is worried about that, erase it on this side, put it on the other side. Now that we have it equal to 0, think about the problems earlier on in the section. We're going to factor it and solve it. Hopefully by this time we can factor this without doing the snowflake because this just is x and x. How does 24 break up so it subtracts to give you 5? That would be 8 and 3. To get a positive 5, I need a positive 8 and a negative 3. Solving. I can equal 0 and solving it, change that sign. I can equal 0 and solving it, change that sign. Now, think back to the Pythagorean theorem problem. If this makes one of the sides either 0 or negative, it's bad. So the side of my garden could not be negative 8 feet. That doesn't make sense. But it could be 3 feet and 8 feet. You'll often find that on these problems, the other side is this number, just with a different sign. So we need to find x equals and x plus 5 equals. And hey, 3 plus 5 is equal to 8. There is our handy dandy answer block from back in chapter 2. Then we have to write the answers here. The x plus 5 answer goes on top. So if you need to, rewrite the answer block so that the x plus 5 comes on the top. Because sometimes people will write it backwards and they'll put 3 here and 8 there. Then it's wrong. So x plus 5 is 8 and x is equal to 3, but we do have to label. This is an area, is feet squared, but these are sides. Volumes get the units cubed, areas get the units squared, and everything else like bases, heights, perimeters, things like that, will get units regular. We can't put UN, we have to put feet. Chapter 5, Section 8, Question 5, Type 2 of 2. We couldn't just stop with just giving you a word problem. We have 2 choices of the types of word problems we could give you. So this time we have a triangular garden, triangle having 3 sides, and you'll notice this little dashy line here in the center, that's the height that is perpendicular at 90 degrees to the base. We'll get into perpendicular some more in chapter 3. So we have a triangular garden with a base that is 2 more than the height. The base is 2 more than the height. If the height is x, it is 2 more than the height. Remember that we switched the order around because of this phrase more than. I could also use the phrase less than or subtracted from, which we covered back in chapter 1. The area of the garden is 12 square feet. Hey, we're using feet again. I left this up here from the last section. This is how we learned that the area of a rectangle is length times width. But to find the area of a triangle, I could actually make a triangle by going diagonally here and just looking at that. It is half of the length times the width. That is the area of a triangle. Area of a triangle is 1/2 the length times the width, or in this case, we're calling it base and height. Base being the bottom and height being this distance perpendicular to the base. You might not like having it written that way. You might also write it as area equals base times height divided by 2. This is probably a little easier to work with, making your common denominators, because some people want to make a common denominator on these as well, but they're all being multiplied. So this is probably the better one for the work that we're doing right now. The base is the bottom, the base is 2 more than the height, and the base is 2 more than the height is x. Formula, plug, work, answer. The area is 12 equals the base times the height. I want monomial first and binomial second, divided by 2. I need common denominators. This has a 2 in the denominator. This needs a 2 in the denominator, and to be fair, I put a 2 in the numerator. I'm already starting to prepare you for chapter 6. We have an equal sign and common denominators. Pew pew! 2 times 12 gives us 24. Distributive property, we get x squared plus 2x. We want this to be equal to 0, just like we did in questions 1 and 2 and 3. All right, we're going to get it on one side equal to 0. I am not a teacher who needs everything on one side. Well, I do need it on one side, but I don't need the equal 0 to be on the right-hand side. We have x squared plus 2x minus 24. Once it's equal to 0, the next step is we're going to factor that. X squared will break up nicely into x times x. 24 needs to break up in a way that subtracts to give you 2. That is 6 and 4. It's going to be a positive 6 and a negative 4. I can equal 0 and solve it. You'll get x equals negative 6. I can equal 0 and solve it. And you'll get x equals positive 4. Can the height be negative 6? No, it cannot. Now, someone said, hey, do we just cross out the negatives? Not necessarily. We don't cross out the positives necessarily. We always have to check it against this picture to make sure that none of these sides or heights or lengths or widths become 0 or negative. In this case, because this is just a plain old x, then it works. We have x and x plus 2. So since I have x plus 2 on the top, I'm going to make a beautiful answer block with x plus 2 on the top and x on the bottom. X is equal to 4 and x plus 2 equals 6. There is our beautiful answer block, and I have them in the same order as defining my variables, so I can just bring them over with 6 and 4, because somewhere, if you find this first and the other one second, you'll have those switched. Feet squared, these are not volumes, they're not areas, so therefore they get feet regular. And you might double check. 6 times 4 is 24, divided by 2 will give me 12. It works.